Hello everyone, welcome to our class. This class we will study chapter 10, radiation. The first section we will study some concept of radiation. Just is some basic concept about radiation. Give some review about radiation. Thermal radiation is electromagnetic wave emitted due to the agitation of molecules of substance. So radiation is very traditional knowledge. It is an electromagnetic wave. Any substance with higher than 0 degree Kelvin can emit the radiation. Radiation is similar to light wave in that it is propagated in straight line at the speed of light. The speed is very fast. 3. Radiation striking a body can be absorbed, reflected by the body, and transmitted through the body. For example, here is a body. When radiation strikes to the body, some part of the radiation reflected, some radiation absorbed, some radiation passed through the body. For radiation striking a body, the energy can separate 3 parts. QA, Q alpha, Q low, and Q tau. 3 parts. Alpha means some receive absorption. Low means reflection. Tau means transmission. So we order 2 sides divide Q. So Q alpha over Q plus Q low over Q plus Q tau over Q equals 1. So in this case, alpha we can call it absorptivity. Low is reflectivity. Tau is transmissivity. Tau. Therefore, alpha plus low plus tau equals 1. Everyone is in 0 to 1 in this region, in this range. Okay, if the absorptivity is very big, certainly the reflectivity and the transmissivity certainly will be small, like a non-matter body. In this case, alpha is very big, but reflectivity and transmissivity is small. If the absorptivity is small and also the transmissivity is small, reflectivity certainly will be big, like a metal body. Okay, the section 2, black body radiation. Very important law is Stephen Boltzmann's law. The law says emissive power of a black body is directly proportional to force power of its absolute temperature. Here is Stephen Boltzmann's law. Tell us the black body emissive the energy proportional sigma T power force. T is absolute temperature of the body, directly proportional. Where the unit is W is watt per square meters. The subscript B means black body. Notice the constant sigma equals 5.67 times 10 power minus 8 is very special. 5678. The unit, the sigma is a constant, but it has some unit. Watt per square meters per Kelvin power force. It is include some unit. Black body certainly is very special body. Another body is practical body, general body. We know any practical body has smaller emissive power than that of black body in the same temperature. The ratio of the emissivity power of practical body to the black body is called emissivity. Sometimes we can call it blackness. Just E is practical body emissive power over EB. EB is black body emissive power equals epsilon. Epsilon is blackness. So for any practical body, we have E equals epsilon sigma T power force. Because sigma T power force is only for black body, so epsilon means smaller than 1. Black body emissive power always larger than practical body, practical real body. Another law is Kirchhoff's law. It tells us absorptivity alpha corresponds to obtent. However, the degree emissivity blackness means give, to emit. So epsilon and alpha is different concept. Alpha means obtaining, epsilon means emitting. How is their relationship? Consider a practical wall and black wall to consist a system. For example, here is real wall, practical wall. Here is a black wall. From the practical wall, give some emit power E. All of E be absorbed by this surface. However, from the black wall, give the energy EB. Only part of energy be absorbed by practical body. Another energy reflected. So we obtain the practical wall emits the energy is E, which is absorbed completely by black wall, by this wall. It receiver the energy is only EB times alpha, means here EB times alpha. So it receives the energy is EB times alpha. Another 1 minus alpha times EB reflected. Finally, the practical wall get the net energy is Q equals alpha EB minus E. There is some difference. If the temperature T1 and T2 is the same, certainly this equation also is right. However, in this case, Q must equals 0. So Q equals 0. In this case, E over alpha equals EB. Also, E equals alpha EB. You can find, last page, E equals epsilon EB. Here, E equals alpha EB. What's meaning? Means alpha equals epsilon. So, the emissivity of a body radiating energy at temperature T is equal to the absorptivity of the body when receiving the energy from a source at temperature T. Here is T. In this case, Kirchhoff's law tells us if a body has bigger absorptivity, it also has strong emissivity. Alpha always smaller than 1. So black body emission power certainly larger than practical surface emissive power. From the equation E equals epsilon EB and E equals alpha EB, we know epsilon equals alpha. At the same T, the surface temperature equals the source temperature. in these conditions, under these conditions, we know epsilon equals alpha. Thank you.